Hello, how are you? Well, I'm going to correct the homework that I sent the other day. The first exercise is the 32, page 154. So in that exercise, you had the constant of proportionality. So you had to write the formula of this function of direct proportionality. So this function has the formula y equals 3 3/4 because the constant of proportionality is 3/4. Okay, sorry, I wrote that here. So 3/4 times x. So that's the formula of this function. Then we have to make a table with values in order to represent the function. So here you are the table of values. So we give numbers to the x. Okay, this is the independent variable. So these numbers, the 0, -4, 4, 8, are invented by me. Okay, so I gave these numbers to get exact numbers, integers. If I give different numbers, for example, 2, and I substitute this number in the formula, I get a decimal number, that is 1.5. So, well, it's not a problem because this number is not difficult to represent. But if you can give numbers to get exact whole numbers, not decimals. Okay, that's better to represent the function. But anyway, you can give any number to the x. So for -4, the formula is 3/4 times -4. So 3 times -4 is -12 over 4. So this is -3. Okay, -3. For the number 4, you get 3. And for the number 8, you substitute in the formula the number 8. It is 24 over 4, 6. The number that you get. After you have the table of values, you can represent the function. So these points are the points that I have in my table. Okay, so the 0, 0, the 4, 3, the 8, 6, and the -4, -3. Remember that this function is a straight line that goes through the point 0, 0, always. Okay, now we continue with exercise 33. In this exercise, you had to link each formula to the correct line. So to do this, you have to make a table with a pair of numbers. You give a number for the x, sorry. You give a number for the x, and you get a number for the y. So 2 times 1 is 2. When you have this point, the point 1, 2, you go to the coordinate plane and you look for that point. That point, the 1, 2, it was the 1, 2, is here. So that formula corresponds to the line 3. Okay, the line 3. We have to do the same for the rest of formulas. So in the second one, y equals 3x, you give a number to the x, any number. But remember that you should give small numbers, because if you give the number 20, the number 20 is not here, okay? Because we only reach the number 2, 3, 4, 5, 6, 7. This is the 7. So you cannot give the 20 or the 30. So give small numbers, small whole numbers, small not decimal numbers, non-decimal numbers, okay? So if you give the number 1, you can give the same number, okay? Or, well, here I gave the number 2, but you can give the same number. So you give the number 1, we get the 3. So the point is the 1, 3. The 1, 3. The 1, 3 is here. So is the line 2. Okay, the line 2. For the third one, the 1, we get the point 1 minus 2. The 1 minus 2 is here. So this is the line 1. And finally, for the last formula, we get the 2, 1, the 2, 1 that is here. So obviously is the line 4. We continue with exercise 53 on page 158. So in this exercise, the question was if these two tables are functions. Well, so we are going to observe the first table. So let's take a look at the table. So in the independent variable, the x, we cannot repeat numbers. So in this case, we have the minus 2, the minus 1, the 0, the 1, the 2. So we don't repeat numbers. So yes, this is a function. Okay, it's correct, it's a function. Let's see the second relationship. 0, 1, 2, 1. So we are repeating the number 1 in the x. When you repeat the same number in the x, this is not a function. Okay? Well, this is only for the x. In the y, there is no problem. We can repeat the same number. For example, in the first table, we repeat the number 3. But it's okay. Yes, we can repeat the same number for the y, for the dependent variable. It's not a problem. The question is if we repeat the same number for the x. I have represented the second table on a coordinate axis. So you have the points here. Well, this point, the 228, well, it's here, but it's obviously not correct because each square is 1 unit, but the 28 is very, very, very high. So I couldn't represent that correctly. Okay, but well, is this point. Good. If you see the the x coordinate equals 1, okay, this one, we have two different points. The 1, 4, okay, the 1, 4, and the 1, minus 6. So for the 1, we have 2 points. In that case, this graph is not a function, okay? Let's finish the last exercise. 68 on page 159. You had a graph. On the y-axis, you have the number of mosquitoes, and on the x-axis, you have the number of days. The first question is how many mosquitoes there were initially. There were at the start. So at the beginning, we start with 2, but the number is in thousands. So there were 2,000 mosquitoes at the start. The second question is, when was the insecticide used? If we see the 4th day, the number of mosquitoes decreased a lot. So we have to suppose that on this day, the 4th day, or after 4 days, the insecticide was used to eliminate the mosquitoes. Okay, so after 4 days, the number of mosquitoes decreased a lot. So on this day, the insecticide was used. Okay. The third question was about if the mosquitoes were eliminated completely. So on the graph, we see that on the 8th day, the number of mosquitoes increased again. So the mosquitoes are not eliminated completely because they start to increase again. So here you are the answer. On the 8th day, the number of mosquitoes start to increase. Well, I hope you understand all these four questions. Please, if you have any question, ask me on Edmodo. Bye bye.